Welcome to aminacademy.com. In Discrete Mathematics, let us discuss about congruence relation. If a and b are integers and m is positive integer, then a is congruent to b modulo m if m slash a minus b. The notation is a is congruent to b mod m, which says that a is congruent to b modulo m. We say that a is congruent to b mod m is a congruence and that m is its modulus. For example, the integer 2, 9, 16 all leaves the same remainder when divided by 7. The special relationship between the numbers 2, 9, 16 with respect to the number 7 is indicated by saying these numbers are congruent to each other modulo 7. We can write this as 16 congruent to 9 congruent to 2 mod 7. That means 2 is divided by 7, the remainder is 2. 9 is divided by 7, the remainder is 2. 16 divided by 7, the remainder is 2. So these three numbers are divided by same number, that is same any number, that is mod 7 here, then leaves the remainder 2. So these are congruent to each other. For example, suppose, look at here, 87 is congruent to 23 mod 4. Means 87 is divided by 4. Since 4 divides 80, since 4 divides 87 minus 23, which is equal to 64. That means if you subtract 87 minus 23 gives 64, which divides 4 divides 64. Like one more example, 72 is congruent to minus 5 mod 7. Since 7 divides 72 minus of minus 5 equal 77. Now look at here, this negation, that is 27 is not congruent to 8 mod 9. Look at here, since 27 minus 8, which is equal 19, means because 19 is not divisible by 9. Hence 19 is not divisible by 9, so it is not congruent. Now some theorem we can look on this. First one, for any integer For any integer a, we have a congruent to a mod m. Second one, if a congruent to b mod m, then we can say b congruent to a mod m. Then if a is congruent to b mod m and b itself congruent to c mod m, if it is like, we can say then a is congruent to c mod m. Here, suppose m is positive and a is any integer. By division algorithm, there exists integer q on r with 0 is equal to r less than or equal to m, such that a equal to mq plus r. Then mq equal to a minus r. Suppose we have a equal mq plus r. Then mq equal to a minus r. Then m divides a minus r. Then r, you can say a is congruent to r mod m. Now residue classes. What is meant by residue classes? The set of elements such as integer that leaves the same remainder when divided by given modulus. These are residue classes. Further, for each integer a, we define residue class of a is equal to x, such that x is congruent to a mod m. In other words, residue class of a is the set of all integers that are congruent to a modulo m. We call residue class a the residue class of a modulus m. Since some people says we call the bracket a the congruence class or equivalence class of modulo m. This congruence class or equivalence class. Now, some residue class modulo, for example, the residue class of the classes of modulo m equal to 6 is, suppose it leaves 0, that the residue class of 0 equal, we can write minus 18 minus 16, so minus 12 because 6 less here, minus 12 minus 6, 0, 6, 12, 18. That means if you divide these numbers by 6, we can get 0 remainder. So it's called a residue clause of 0 is this set of values. Suppose we are getting residue 1 minus 17 minus 11 because 1 remainder minus 5 1 7 13 19. These are the residue clause set of numbers for residue class 1. For 2, residue clause of 2 is same like minus 16 minus 16 minus 10 minus 4 then 2 8 2 8 14 20. Like all classes you can write residue clause of 3, residue clause of 4, residue clause of 5, up to 5 you can write because modulo 6 here. So you can fill here is minus 13 minus 7 minus 13 minus 7 minus 1 5 11 17 23, like it continues. These are complete residue class of modulo 6. Now we'll discuss one more theorem here. Look at here. If A plus B is equal to C plus D mod M, then we can write and B is congruent to D mod M. Then you can say A plus B is congruent to C plus D. That is A plus B, A plus B congruent to C plus D mod M. Then you can say A plus B is congruent to C plus D before that we will write this given things first. That is here, suppose A congruent to C mod M and B congruent to D mod M. Then you can say A plus B. That is here lefts are ordered. A plus B congruent to C plus D mod M. Then second you can say A dot B is congruent to C dot D mod M. For example, observe this one. 2 is congruent to 8 mod 6. Mod 6 and 5 is congruent to 41 mod 6. Then we can see 2 plus 5. From this theorem, we can say 2 plus 5. 2 plus 5 is congruent to 8 plus 41 mod 6. Look at here, 2 plus 5 is congruent to 8 plus 41 mod 6. Similarly, you can say for product also, 2 into 5 congruent to 8 into 41 mod 6. Third one, for example, p of x equal 3x square minus 7x plus 5, and for x is 2, p of 2 equal 4, 2 squared is 4 into 3 is 12 minus 14 plus 5, 7 into 2 is 14 plus 5, which gives 3. And p of 8 is 192, that is 3x square, 192 minus 56 plus 5, which is equal 141. From this we can say, hence we can say from this result, 3 is congruent to 141 mod 6. Like that we can express in modulo form. Now, in general, you can say integer modulo m, that is z. Generally, integer modulo m, that is, you can say zm. Now, what is cancellation law for congruence? Next is cancellation law of congruence. Here, first cancellation law, if A into B congruent to A into C and A is not equal to 0, then you can say B equal to C, means A is cancelled, because both side A is product with B and C, then B equal to C you can say. For example, 3 into 1 equal 3 into 5 mod 6, then but 1 is not equal to 5, 1 is not equal to 5, mod 6. Thus we cannot cancel the 3 even though 3 is not equal to 0. However, we do have the following modified cancellation law also can apply for this. Here even 3 is not equal to 0, but here 1 is not equal to 5. So because 1 is not equal to 5 mod 6. So we cannot cancel here. Therefore, you can see, look at here. Suppose AB is congruent to AC mod M and D is congruent to GCD, greatest common divisor, GCD of A comma M, then you can say B is congruent to C mod M slash D. So far we discussed about residue class of mod as well. This congruence relations. In congruence relations, we discussed about congruence relations between numbers as well residue class of that given numbers. We have done. Please subscribe our YouTube channel.